Hello, this is Mr. G. There is a link on our webpage for the class that, well, this is a picture of it, right? 1D kinematics, sample problems and solutions. You should click on this and start doing those problems. I'm going to work some of these out right now, actually. But again, there's no substitute for doing the problems yourself with no help or guidance from anyone else, right? Other than yourself. So here we go. So also, after you work these out, you can click to see the answer, and then you can also click the button below that to look at the solutions. You should do that. But I'm going to work out some of these anyway. So airplane accelerates, etc., right? So if you've read the problem-solving strategies, right, that are on this webpage and that I've talked to you about, you want to make a diagram of some kind to help you with this problem. At least I have to make a diagram. So here's my picture. Ground, airplane. Right, so it's actually still on the ground right now, and it is starting at rest, okay, before it takes off, yeah. So V naught is 0. So, I should redraw the ground because it kind of looks like that airplane's just is floating above the ground. That could be confusing. Hold on. There we go. Yeah, it's on the ground. And then it's going to accelerate down the runway. So it's going to gain speed. And at some point over here, it's going to take off. Right, once it's going fast enough. Okay. And so the question is, determine the distance that it moves from when it starts to when it takes off. So that's delta x. So I'm going to just list the quantities in this problem that I know. Well, I've got one of them listed already. I know that V naught is 0. I also know that gives you the acceleration. That's 3.2 meters per second squared. That's how much speed it's gaining every second. It gains 3.2 meters per second of speed every second. So 3.2 meters per second, which we write in this notation, meters per second squared. And they give you the time, 32.8 seconds. And that's the information that you're given, all right? So I want to do one other thing here that's not strictly necessary for this problem, but it's a good idea to start doing this anyway. And that is establish a coordinate system. So for my coordinate system, that's just pretty straightforward. This is the origin, that's where the plane takes off, and positive is towards the right. And now I need to decide, okay, so which of those 4 equations could I use? And the thing is, the equation has got to contain these 3 variables and also the variable I'm looking for. So again, this amounts to solving for the unknown. It's an algebra thing, all right? So yeah, there is an equation out of those 4 that does that. And that one is delta x is equal to V naught times t plus 1/2 at squared. And by now you should be saying, oh, what, that one again? Yes, it shows up a lot. There are only 4 of them that we use. And if you're saying, wait, where did that one come from? You need to do some more studying. So the first term right here, V naught is 0. And so 0 times t, doesn't matter what t is, that first term goes away because it is 0. Bloop. 0. That's a little notation that I used to remind myself it's not there anymore. So now the equation becomes a little simpler. Delta x is 1/2 at squared. And that's not to say this is simple. It's not. It's complicated. But if you practice and practice, it will start to become simple. All right, so now this is straightforward. So we don't have to rearrange anything. Just put in the values for a and t and do the math here. So delta x is 1/2. The acceleration is 3.2 meters per second squared. And the time is 32.8 seconds. And of course, I'm running out of room here. Yikes, it's got to be squared up here. And the units here are seconds. So, then let's do the math. Okay, let me erase some of this over here. And so the answer that my calculator is telling me is that delta x, the answer my calculator is telling me is that delta x is, it says 1,721.34 meters. And so remember, there is a concern here, or there is a need to keep the number of significant figures consistent. So look at the problem. Look at the way the numbers are represented in this problem. That has 3 significant figures, and this has 3 significant figures. So your answer should have 3 significant figures. That just means you're going to round this answer to 1,720, right? Because the 1, the 7, and the 2 are significant. The rest, like I said, round that little 1 down there to 0. So then, and that's it, meters. 1,720 meters. Now, on the exam, right, yeah, the answers are going to be represented in, with the correct number of sig figs, but if you're just doing a problem like this and you're not turning it in or you're not submitting it online to the homework program that we have, that's not that critical of a thing, but if you are submitting it to the homework server, then you need to stick with the correct number of sig fig. And there you go. That is problem number 1 here. So I'm looking at my little clock down here. It says 8 minutes. Now, that's because I'm working this slowly and I'm taking breaks and talking to you and explaining things. You need to get to where you can do a problem like this in about 2 minutes. You could do it, but it takes practice, okay? All right then, next problem. Actually, I'm just going to stop this one right here and then do a completely separate one for the next problem. So we are done here.